This is Dan Abbott. I am one of the instructors in the Casco Bay Flotilla of the U.S. Coast Guard Auxiliary course in Advanced Coastal Navigation, and I'm making this informal video as a means of helping students in that class understand how to approach Problem 19 in Chapter 7, which is the chapter on current sailing. This is the problem from the workbook, Problem 7-19, and it indicates that we're on a trip. If you take a look at the piece of the chart on the right-hand side, we're going from the Buzzards Bay Light, which is represented by that lighthouse symbol, and we're going to go from there. At this point, we're going to go directly to the Saginaw entrance light. The problem is that we've checked and discovered that there's a tidal current running, and it indicates that we've estimated that current as 060 direction, and the drift is 1.1 knots. So the set's 060, the drift is 1.1 knots, or the speed. So it checks more or less with the predictions in the tidal chart and the tidal current chart, and that means that's the best information we have. So we're going to take that into account so we can point the boat in such a direction that'll be more likely to move along that track. It indicates at 1400 we're going to pass close abeam Buzzard's entrance light. Buzzard's entrance light is right here. So we'll go over and we'll start on the chart by identifying that as a fix, putting the time 1400 there, laying out a track line because it indicates we'd like to go in a certain direction. Track line, by the way, is sometimes called a course of advance, but it's really the track we want our boat to take, which means we need to point the boat at a different course if we know we have a set and drift. So here's our chart. We're starting in this area right here. We're going to that light right there. It tells us what our current set and drift is, and it indicates when we're going to start at Buzzard's light. So we'll zoom into Buzzard's light, and the first thing we'll do is indicate that we have a fix. So we'll put a dot right here. We'll indicate that the time that we're going is 1400. I'm going to move that time down a little bit because I know it's going to be in the way. So the dot with a circle around it indicates that it's a fix. The time at horizontal, drawn horizontally, also indicates that it's a fix. Now it tells us that we have an estimated current with a set of 060 and a drift of 1.1. We don't need to draw that on the chart right now, but just to help you visualize, I'm going to go ahead and do it. So I need an arrow that's dashed arrow that points in that direction and is at a specific length, and we'll assume that this set and drift vector was generated after 1 hour. So our set and drift vector will look like this. Then we need to write above it our set and below it the drift. So when we're done, we'll have a one vector on the drawing on the chart right now. The set is given above, the drift is given below, and it shows us we're being pushed to the right and backward from the direction we want to go, which means we know we're going to end up going slower than our speed through the water because we have a foul current. We also know if we're going to compensate for that, we need to point our vessel to the left of our intended track. Now let's get the intended track. The intended track is a line that's going to go directly from Buzzard Light over to black and white SR. So we'll go ahead and draw a line. This would be a solid line from here to here, which now gives us our track. Now we need to know what the direction true, everything we're doing is true, not magnetic. So we need to know what the direction true is going to be. So in order to do that, we would take this line and we would use a parallel or some other device to determine the angle. What I'm going to do is take that line and put it right through a compass rose. So using the software that I'm working with, which by the way is AutoCAD, I'm going to take this line, I'm going to copy it by selecting the line itself, find the nearest compass rose, make sure the line goes right through the center of that compass rose. Then I can move out to the outer ring to determine what the angle is. If I look, this 280 goes to 290, so it's 28567. 287 is the direction true for our track. That's what we hope our boat will accomplish. So we'll go back and we'll put that above the track line so that we know what we've got going. And I'm going to preface that with the letters T. So there's our track. And normally what we would put below it is our speed of advance. In other words, the speed that our vessel will be making as it goes through the water. But we don't know that yet. We need to calculate that, so there's nothing to put there right now, so I'm just going to leave it the way it looks. So we're starting by having a fix at Buzzards Bay Light. We've drawn the set and the drift vector just so that we can see what the effect is going to be of our tidal current. I've drawn a track line directly from where we are to where we'd like to go, determine what the direction is, and labeled that as TR for track 287. Now what happens next? We know our speed through the water is 6 knots. That means we're going to be going at a specific RPM that we know our boat will, that we know results in a speed through the water of 6 knots. At this point, in order to find out what our course should be, which way we should point the boat, and our speed of advance, we need to switch to a maneuvering board. Maneuvering board looks like this. It's really a series of rings, equally spaced, starting at an origin and going out 1 unit, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this maneuvering board allows us to do some vector math quite easily. What we're going to do is to draw the track line. We're going to then draw the set and drift vector, and we're going to use that information to determine a new course and the speed of advance that we're likely to be going through the water. First, the track line. And the track line will start at 0, 0, and it's really, at this point, we don't know what length to make it. It's going to be a just go beyond the edge, and so we're just going to go over and find our 287, which is 285. 287 goes right through there. We draw the track line, and once again we'll label the track line with TR 287 above. We don't yet know the speed of advance. So it's going to look like this on a maneuvering board. Next, what we need to do is lay out our set and drift. We know the set and drift vector is a length of 1.1, because what we're doing here is every one of these values represents a speed right now. So we'll go ahead and do a set and drift vector, which is going to be pointing off to so a set and drift vector will look like this. It's pointing at 0, 6, 0. We know that because if we go all the way out along this line, it's got this 6, 0 here, and it's 1.1, and we're estimating that because that ring represents 1, that ring represents 2, 1.5 is here, so we're just going out beyond until it looks like about 1.1. Now we'll label the set and drift vector as well, set above, drift below. When we're done, our set and drift vector looks like this, our track line looks like that. Now this next part is really interesting, but it can be a little counterintuitive for people. What we need to do is to figure out where along the track line I can draw a point that represents our course line. Now what we know about the course line is that we know that we're going to be going at a speed of 6 knots through the water. That's what we hope to accomplish. So what we need to do is to put a 6 unit long vector on that maneuvering board in such a way that it takes into account the set and drift, and then shows us where along the track line to draw our course line. So we'll go back to the maneuvering board. I'm going to accomplish this by drawing a circle whose center is right at the end of our set and drift. So it's going to be right there, right about there. Now I'm going to make that circle a radius of 6. What that means is the circle that I just drew is 6 units away from that point right there, which means now when I draw my course line, I can draw a course line that goes from the intersection of that arc, from the intersection of this arc right here, all the way to the end of this line right here. So that is my course line. You can see that it starts out at the set and drift vector. It's at the center of the arc that I drew right here. I'm just going to trim that arc up a little so that it's not a full. So now that course line, the line that we just drew, tells us what direction we need to point our boat. What I need to do now is to find out what direction that's pointing in. And what I'm going to do is to take, and again I would use probably a set of parallels, and take and make a copy of this so that it goes right through the center of our maneuvering board like that. And then I would extend that out to determine what the course line is going to be by reading the direction on this outside ring. So if I extend this out by just drawing a line that continues on through, then come out and read this value, you'll notice that it is 279. So our actual course is going to be 279. That means we're going to point our boat at 279 in order to achieve a track of 287. And that's pretty logical when you look at it to see if we're being pushed to the right. We're going to have to move our course so that we're going to the left. The 279 is our course line. We're going to go back now and we're going to put that on the chart. But before I do, I want to determine what our speed of advance is. And the speed of advance is represented by the length of the track vector starting from 0 and going out to where that arc is right there. So if I zoom in and estimate, I've got a ring right here that has a 5. and I can see that it's not quite halfway between the 5 and the 5.5, so I'm going to estimate that speed as a speed of 5.2. That speed of 5.2 becomes my speed of advance. I'm going to put that under this line as an SOA, speed of advance, and then I'll label the course line, then we'll go back to the chart. So now on the maneuvering board, what we have laid out is a set and drift vector labeled as set 060 above, drift dr 1.1 below. We have a track line that we initially drew with no fixed length. We label that TR287 because we know that's what we hope our boat will do. That's the track we intend our vessel to follow. We've now calculated by using a distance of 6 units from the point of the set and drift vector till it crossed the track line. We've determined that the speed of advance along the track line will be 5.2, which is the distance that arc is from the center. We've also determined that the course is going to be the angle of that line, course of 279. We take a sort of common sense look at it and say that does make sense since we'll be pointing to the left. And we know the speed through the water is 6.0 because that's a given. That's what our intended speed through the water. Now we'll take this information and we'll take and put it on the chart so that we can use it as a way of determining what our next course is. So when we're done, our lines might look like this. Though I have something that's not normally a convention in dead reckoning. I have the course line 279 true, and I just leave that open, and then after that I have labeled that incorrectly. 294 magnetic. In order to differentiate them, what I normally do in my charts is I indicate the true course with a T and the magnetic course with an M. But the convention is not to put anything and to put everything on your chart true. Now you'll notice, pull that back here a little bit. Now you'll notice our track line is what we intend the boat to do. We hope our boat's going to go along here. In order to accomplish that, since we're being pushed to the right and back, we're going to point our boat along this course line, and as a result, as we move along, even though we're pointing on the course line, we hope to be kind of crabbing along that track line. Our speed through the water is 6, but because we have a foul current, our actual speed of advance we're estimating to be 5.2. Now at this point, we're going to lay out some DR locations, and those DR locations have to be laid out on the course line, not on the track line. Anybody that has looked at some of the solutions slides, one of them has it as an error, I'm afraid, but just make a point of noting that any DR is placed on course lines, not on track lines. So what we'll do is put a DR along the course line 30 minutes out and another 30 minutes out, so we have an hour. So we'll put one at 1430, we'll put one at 1500. So in order to do that, I need to have a dot with a half circle, and because we're going 6 knots, 30 minutes out would be 3 miles. So I'm going to move 3 miles along the course line, put a DR location, go another 3 miles and put another DR location. So our DR locations now have been identified with a dot and a half circle, because a fix, we know where we are when we do a fix, we do a full circle. DR is where we would be if we had no set and drift. Now this is sometimes confusing to people. We're going to point our boat along that line. That's the direction our boat gets pointed in. Without any set and drift, we would end up being here at 1430 and we would end up being here at 1500. We don't think we're going to be there. We think we're going to be along this track line because we've taken into account set and drift. But at 1500, I'd like to find out what my current set and drift is and compare it to where I expect it to be and see how it has changed over that hour, because tidal currents do change. In order to determine the actual set and drift from our own progress, we need to use a course line. We need to point the boat 279, we need to run it at 6 knots, and we need to keep careful track of time in order to determine at 1500 where we actually are. Where we hope we are is going to be on the track line someplace back here, based on the set and drift. In fact, if we were to copy our set and drift vector and then take and move it so that it sits right on our DR right there, we would end up with an estimated position, and the estimated position we would expect to have is going to be right on the track line right there. If I had done everything correctly on this, that estimated position would have landed right on the track line. So I'm going to go back and check and make sure that that vector right there is the right length. I think it's not, so I'm going to change it. I'm going to draw a line, and I'll draw that line starting right here, and I'll have the line go 1.1 at an angle of 60, which would look like that. Now I'm going to copy that. I'm just using this for length right now. I'm going to copy that from here, go back over to our 1500 DR position, and that should land right on. Yeah, and it does. So what I'm doing is trying to find what I would call an estimated position. An estimated position would look like this: a dot with a box around it. Now, right now, the only reason for that estimated position is to sort of figure out, when we do now get a new fix, how the set and drift vector has changed. It started off being 0, 6, 0 at 1.1. If nothing had changed and we run our course line as intended, we should be right there. So what I'm going to do now is to get a fix. Now, in order to get a fix, what we need to do is to use the information given in the problem. So our first landmark is going to be this abandoned tower right there over on Saginaw Point. And we know by using our handheld compass that from our vessel it bears 320 magnetic. Now that's given magnetic because we're using a compass to determine it. We need to then convert that into a true heading. The true is going a true bearing. So 320 magnetic minus 15 west as our variation gives us 305. We're also going to be using a tower on Gooseberry Neck. From our vessel, that bears 073 magnetic, which when we do the conversion to true is 058 true. So we'll go ahead and do a track line. And I'll do that track line first by going to a compass rose and then locating on the compass rose a line, or drawing a line at that angle. So if I start right at the center, and I'm going to go right out through 305, I'm going to draw my line a little longer than the compass rose because I need to have it a little longer. So you notice I'm at 300, and right there is going to be 305. I'll take that line now, and I'll use a set of parallels or some other device to transfer it up here. So there's the direction that I want. I need to make sure the line itself goes directly through our landmark. Our landmark in this case is this abandoned tower, so I'm going to put it right here. So we now have one line of position, and that actually is pretty encouraging since it goes right through the estimated position. You might decide to stop here, by the way, and go, oh, that's good enough. However, that is not good enough. And the reason it's not good enough is we have another line of position, so we're going to use that first. Now we'll label this by putting the time above and the bearing below. The time is 1500 because that's when we're taking these positions. Because don't forget, we're at our 1500 DR. We're trying to find out where we actually are, so we start with a line of position. The 1500 indicates the time we take it. The 305 is a direction true to the abandoned tower. Now we'll go back over. Now we need a 058 line of position. We'll do another line that goes right through the center. 058. Now be careful. As you're looking at a compass rose, you have an inner ring, which is the magnetic direction. Then you have an outer ring. The outer ring is the one we want. So 058. I'm going to go a little beyond as well. 058 would be putting it right through here. So now I've got that line at that bearing. We'll move that line using our parallels or some other tool. We're going to bring that over. And we're going to drop it directly on that tower right there. Now, we need to lengthen this line, so I'll do that so that it does extend down beyond our first, and you'll notice that will now become our fix. That's where we ended up. So we're going to put a fix there. Now, you notice we could have thought, gee, estimated position must be right because it's also on a line of position. However, it's not the case when you actually plot the other line of position. So I'm going to trim that line off so it doesn't confuse us. I'll just grab it and delete it. So now we're going to have a fix, and we'll locate that fix right here, and that's our 1500. So now we have our red line, which is our track line. That's what we hope to achieve. That maroon line is our course line. That's the direction we pointed our vessel. Had there been no set and drift, we wouldn't have needed to have a course line off the track line. But since we took the set and drift into account, if nothing had changed, we would have been right there after 1 hour at 1500. At 1500 from our DR, we calculated what the actual position was, which is that fix. Because we ran the course line, we can now determine what our current set and drift is. And as you can see, the direction of the current is shifting over an hour, which is quite common. So that was our set and drift an hour ago. Now we have to determine the set and drift right now based on the distance from here, where we would have been had there been no current, to here, where we actually ended up. We'll draw a set and drift vector and we'll label that one. So that's the new set and drift. The set and drift of 018. The set would be 018, the drift would be 1.1. So the speed of the current hasn't changed any, but the direction has changed, which again is logical over the course of an hour. So what do we do now? Well, we have a new starting point now, and we're going to start our new DR from that fix. That's what we do. But we also now have to come up with a new track. If we're going directly to that light still, we're going to draw a new track line that goes from where we are to where we want to be. Then we need to go back to the maneuvering board using this set and drift information, determine a new course, which of course is still going to be to the left, a new course to determine both the speed of advance and the course we're going to be going. So we'll quickly do that right now. First I'm going to draw a line that goes from our current position, so it's going to be right about here, to where we're actually headed, which is going to be here. I'll erase the original track line just so that it's not confusing us. So we have the track line, we have the set and drift. What we need to do is to determine the angle of that track line. We would take and move it toward a compass rose. So we'll take it, we'll go down, grab the line somewhere on the line itself, go find a compass rose. We'll make sure that the line goes right through the center as we transfer it down. We'll extend it up through to the outer edge, and it's 282, between 282 and 283. I'm going to go with 282. So we have a new track line, and the new track line is a track of 282. We still don't know our speed of advance because that's something we have to get from the maneuvering board. So now that we have a new set and drift and we have a new track line, we go back to the maneuvering board and we calculate the new course line and the speed of advance. We'll start by getting rid of all the things we had on the maneuvering board to begin with. We'll do a new track line now. That track line is going to go through 282, 27, 28, 282 would be right there. We'll put a new set and drift vector, which is going to be the same length, 1.1, but it's going to be an angle, a different angle. So now on our maneuvering board we have a track line. I need to label that as a track, so I'll just indicate that the track on this case is 282, which is different than what it was before. Our set is different at 018 instead of 060. Our drift is the same. We'll go back to drawing a circle. The circle is going to be centered at the end of that set and drift vector still, which is going to be right there, and it's still going to have a radius of 6. We'll now draw a course line that starts at this intersection where that arc goes through. It goes all the way over and it ends right here. So now we have a new course line, which is a slightly different direction. In order to find out what that direction is, I'm going to move that over here for a track line. In order to find out what that direction is, I need to move the course down through the center 0 here, the 0, 0 location of the dead center of our maneuvering board. Extend the line out to see what the actual angle is. Don't make the mistake of extending it from here because it's not sitting on the center. So you still have to make a copy of that or use your parallels and move it down and say, let's start that right at the center. Then you'll just extend that line out so that when you extend it, it will come through. It will come through. Hang on just a minute. The outer ring, and at this point it's very close to 271, very close to 271. So our new course line is now a course of 271, which we're going to write above this line with the speed of 6.0 below. So our new course that we're going to point the boat, again our new course line is 271, and the speed we're going to be going is 6.0. Our speed of advance, which is indicated by where that arc crosses the track line, should have increased since we have a less foul current now. Still have a foul current, but it's not nearly as bad as it was. So if we take a look, there's the ring for 5, there's 6, so it looks like 5.5, 5.6, maybe 5.7. So we'll call our speed of advance. Speed will likely to go through the water. Just speed of advance, we'll call that 5.7 instead of 5.2. So we're going to go slightly faster. We're going to be pointing in a different direction. Now we go back to our chart, and on the chart we're going to put a course line here. So when we're done, this is how we have things labeled, although we have to put our speed of advance in here as well. So the speed of advance goes below. We'll change what that says so that it says SOA 5.7. So we're going to be moving a little bit faster. And our new course line is the 270. In other words, if we point our boat along 270, we hope to be tracking right along here.